Okay, 5.1, we're solving quadratic inequalities now with one variable. So really, this part of chapter 5 is going to be building right off of chapter 3 and 4 where we worked with the quadratics. So again, which strategies could you use to solve this quadratic equation? Well, you were taught 4 strategies to solve a quadratic. 1, we could factor it. And if we factored it, it actually would factor into 5x minus 2 and x plus 3 equals 0. Which would then give you x equals 2/5 and x equals negative 3. So there's strategy number 1. Strategy number 2, we could use quadratic formula. Quadratic formula again was x equals negative b plus or minus square root b squared minus 4ac over 2a. Factoring only works if it's factorable. Quadratic formula works all the time. And just to remind you again, we know that something is factorable when the discriminant on the quadratic formula is a perfect square. So if that's a perfect square there, then we could have factored. Third way that we could do it, we could complete the square. Complete the square and then just start solving for x. Get the same answer in that one. And then the fourth way you learned was graphing. Use the graph and then find where are the zeros. We're looking for the x-intercepts. So the x-intercepts, or the zeros of the graph. Oh, nice. Starting off with a problem. Again, I suggest that you pause and you try to do it on your own. See what you can do and where you need some help. You'll learn a lot more if you attempt this first on your own. Alright, so a rectangular construction site is to be enclosed with fencing. The length of the site is to be 15 meters longer than its width. Well, let's draw it so we can get a visual of what's going on. What dimensions are possible if at least 700 meters squared of land needs to be enclosed? Well, let's start putting those on here. Well, I don't know length and width, so I need to get variable. So let's let x equal the width. So then that's going to be x, that'll be x, and that makes this 15 meters longer, so x plus 15 for your length. Because we're saying we need to have at least 700 meters squared, that means our area can be equal to or greater than that. We'll just write it as the area at the end when we get to the final inequality that they're asking us to make. We're going to say the area is greater than or equal to at least 700 meters squared. But let's just work with 700 right now. Let's make it equal because it'll make the algebra easier as we go along. Well, area is equal to length times width. Area equals length times width. Let's plug in what we know. Let's say we're going to just use 700 to start off with, equal to the length, which is x plus 15, multiplied by the width, which is x. We need to solve for x now. So expand it, and we notice that we get a quadratic. X squared plus 15x And the same thing as always has gone on. If you get a quadratic in this course, you're equating to 0 and then factoring. So then, bring 700 over. 0 equals x squared plus 15x minus 700. And then we've got to factor it. So factor, quadratic formula, complete the square, whichever one you want to work with. We're going to factor it because this one is factorable. Okay, so then 0 is equal to x plus 35 and x minus 20. So that's telling us that the x is either equal to negative 35 or x is equal to positive 20. Well, negative 35 doesn't make any sense because we said that the x is the width. We can't have a negative width, so we know now the width is 20. Okay, so if the width is 20, then the length is going to be, so width equals 20, so then length is 20 plus the 15 equals 35 meters. That's going to give us exactly 700. So if we have any width, if the width then is greater than 20, with the length still at 15, okay, or sorry, length still 15 more, so any width greater than 20 is going to give us more than the 700 meters squared. If we have a length greater than 35, the width would be less by 15, then it's going to give us more than the 700. So to make your inequality now, and inequality just means we're putting in the greater than, less than, those signs, it's going to be the length times the width, or x times the x plus 15, is going to be, that's the area, the length and the width multiplied, is going to be greater than or equal to 700. You can leave it as that. You can expand it, okay, whichever way you want to go. So if we start with a quadratic equation like we had in chapter 3, if we replace the equal sign with an inequality sign, those were greater than or equal to, less than equal to, okay, all of those signs, or even that. So those 5 signs are inequality signs. That gives us a quadratic inequality now with one variable, because we're just going to be looking at x. There is no y, it's just x in here. So those are the 4 main ones that we're going to look at, but does not equal also fits into there. And then we've got any quadratic inequality that falls into those forms. The next section we'll go through with the video explanation of it.
Consider the graph of the quadratic function y equals x squared minus 2x minus 3. The graph intersects the x-axis at x equals negative 1 and x equals 3. So the zeros of the function are negative 1 and 3. The solution of the quadratic equation x squared minus 2x minus 3 equals 0 is the values of x for which y equals 0 on the graph. That is, x equals negative 1 or x equals 3. The solution to the quadratic inequality x squared minus 2x minus 3 is greater than 0 is the values of x for which y is greater than 0. That is, the values of x for which the graph is above the x-axis. Visualize the shadow of the graph on the x-axis. The solution is any value of x less than negative 1 or greater than 3. The solution to the quadratic inequality x squared minus 2x minus 3 is less than 0 is the values of x for which y is less than 0. That is, the values of x for which the graph is below the x-axis. Visualize the shadow of the graph on the x-axis. The solution is any value of x between -1 and 3.
Okay, so bringing those onto a number line now, we've got the solution anywhere between -1 and 3 on the number line, but not inclusive. There were no equal signs in the original question. We want to know where it was not equal to. So therefore, these are going to be open dots on the ends of each of them. If it was less than or equal to, then those would be closed dots. So the critical values divide the number line into 3 separate intervals. There and there. So the critical values were -1 and 3 for the x-intercepts. We've got an area below -1. We've got an area between, and we've got an area above. Okay, so the question now is 3x squared plus 2x, where is that less than 1? Well, in order to do this question, what we're going to start by doing is we're just going to, right now, ignore the inequality. 3x squared plus 2x equals 1. So now we can go back and we can do it the same way that we did it in chapter 3, but then we'll bring in some extra knowledge at the end to compensate for that. Quadratic, equate to 0 and factor. 3x squared plus 2x minus 1 equals 0. And then we factor that. So 3x minus 1, x plus 1 equals 0. So now x equals 1/3 or x equals -1. Those are our critical values. We're going to break this up into intervals. Oh, I should also mention that you may want to pause, watch the video solution for the example 1 in your textbook, and then come back into this and see how I'm explaining it again. But I do have example 1 on for you as well. So we're going to break this up into the 3 sections. Critical values of -1 and 1/3. Break the number line up into 3 particular sections. What we're going to do is we're going to pick now a test case from each of those 3 sections and see which one makes, well, I guess the original ones here true. So we should actually go like this, say 3x squared plus 2x minus 1 less than 0. That's where I want to start with before I make an equal sign. Let's equate it to 0. So pick a test case, some type of number that's in that section. Something that's below -1. Don't pick -1, pick something below -1. -2 is a good one. Pick some value within this interval, something between -1 and 1/3. Well, hey, how about 0? If you can choose 0, choose 0. It's the easiest number to work with on these. So always choose 0 if you can. And then something bigger than 1/3. How about 1? The number that you choose doesn't matter as long as it falls in that section. And what we're going to do is take this and plug it in now to the inequality. See how it works. Do we get a value that's less than 0 here? So let's check. Plug it in. You could also plug it into the original and see if it's less than 1. That would work as well. So 3 times -2 squared plus 2 times negative 2 minus 1. I want to know, is this going to be a negative number? Is it going to be less than 0? And work that through. Negative 2 squared is 4 times 3. So 12 plus 2 times negative 2 is negative 4 minus 1. So 12 plus 4. Hey, you know what? I don't even need to get to the end. I just need to realize that that's not going to be negative. That's not going to be less than 0. So this is false. It makes this inequality false. So this is not going to be one of my solution sets. Then we go to the 0. Do the same thing. Plug that value in and see if it is going to get to a number that's less than 0. So 3 times 0 squared plus 2 times 0 minus 1. That gives us 0 times 3, 0, 0, oh, negative 1. That's why I choose 0, is because it's a nice number to work with always on these. Is negative 1 less than the 0 in this here? That's true. It is less than 0. So this is going to be part of our solution set. Now we're going to do the same thing with the 1. Plug that one in. And see if that's going to end up being less than 0. Let's see. So 1 squared is 1 times 3, so 3 plus 2 minus 1. 5 minus 1, so we got 4. Oh, that's not true. That's false. So that's not part of the solution set. They've asked us to represent this on a number line. I already have my number line ready to go. I know that my solution set is where I had it true. So this section right in here is going to be part of my solution. So I'm highlighting that, and then I have to decide whether or not I put solid circles or open circles at the ends of those. And it all comes down to what this original inequality was. If we have less than, or if we have greater than, I'm going to be putting an open circle. Opened up. If I had less than or equal to, or greater than or equal to, then it includes that point. I'm going to have a closed dot. Because my original was only less than, this is going to be open, and that one's going to be open. There now I have it graphed on the number line right in between the two. Okay. So just to show you a nice, prettier version of it, it looks like this. And then I give my solution, which I forgot to write there for you. Your solution in this area is the x values are going to be between -1 and 1/3, and your alligator signs always go this way. But because the original did not have an equal, I do not put an equal on those two signs. There's your solution. There's it on the number line. You should always throw XER on the end. Oops. Just throw the XER there to say it could be anything in between those values. Well, if the example doesn't factor, we still need to find our critical values. We can't get around that. So we're going to use one of the other strategies. And that would be using your, instead of factoring, using a quadratic formula, or you're completing the square, whichever one you prefer. So relating to the textbook's example number 1, especially if you watch the video solution, you'd have seen that the question that they're asking had open dots. And then this was the answer that it gave. But what happens if we said, changed it to greater than or equal to? At that point, it would include those critical values, the x-intercepts, as well. And the change would be, we would put equal to on those signs as well. Because what we're saying is I want to know where is the graph above or equal to the x-axis? That's really what this says. This one says, where is the graph above, but not equal to, just above, the x-axis. And this one says above or equal to the x-axis. And then when we plot it onto the number line, we also put the equal solid circles. Okay, so solving this one. We've got where is the left side below or less than the right side. Well, easiest way to do these is to expand it, get your quadratic, equate it to 0, and then we'll go from there. So negative 8x less than or equal to negative 3x squared plus 3. Let's bring these over so that we have a positive x squared. So 3x squared minus 8x minus 3 less than or equal to 0. To carry on from here, we're going to change that into an equal sign. So 3x squared minus 8x minus 3 equals 0. Factor it. Hopefully by this point in the course, you're very quick on your own factoring. If not, please be practicing that. So x is equal to negative 1/3, or x is equal to 3. There's our two critical values. So again, number line, put on your critical values, negative 1/3, 3, send that down, and pick a test case in each of those three sections. So something that's less than negative 1/3, just going to take, how about negative 1? Something between these two values, I'm going to pick 0. When 0 is an option, pick it. Something bigger than 3, I'm going to pick 4. Plug these in again to either the original or this. I'm going to take it off of this one and say, where is it? Does it make it a true statement? So 3 times negative 1 squared minus 8 times negative 1 minus 3. Is that going to be less than or equal to 0? Well, we know it's not going to be equal to 0 because equal to 0 is at the critical values. That's why we never ever want to choose a critical value, because it'll always come up as equal to 0. But we want to know, is it going to be less than that 0? And if we work that through, we've got negative 1 squared is 1 times 3, 3 plus 8 minus 3. Is that going to be less than or equal to 0? 3's cancel off. We get 8 less than or equal to 0. That's not true. That's a false statement. This is not part of our solution set. Okay, so then pick the next interval. Do the same thing. This is called a test case. 3 times 0 squared minus 8 times 0 minus 3. We want to know, is that one less than or equal to 0? Working it through, we like 0 because it just goes 0, 0. We get negative 3 less than or equal to 0. Hey, that's a true statement. So yes, this is going to be part of our solution set. And then just check the last one. 4 squared minus 8 times 4 minus 3. Is that less than or equal to 0? 4 squared is 16. So we got 16 times the 3, which gives us 48. Minus the 32 minus the 3, is that less than or equal to 0? 48 minus 32 gives us 16 minus 3, 13. And we know that's not true. So that's a false. So that's not part of our solution set. So then we write down your answer. Your answer is in this section. This is the true interval. So from negative 1/3 to 3, with the x in the middle, and we know we're between those two, and now we have to decide, do we put the less than or equal to sign or just the less than? Got to look back up at the original. If the original one has the equal to sign, we also are going to have the equal to sign. If they ask you to put it on the number line, we're just going to fill in this section, shade that section in, and because it's equal, we're going to have filled in circles. Okay, the length of a rectangle is 3 meters greater than twice its width. The area of the rectangle is less than 55 meters squared. Ooh, as soon as we get the words less than, greater than, that means that this is going to be an inequality question. What are possible dimensions of the rectangle to the nearest tenth of a meter? We want to know what range could we have to be able to make this work. And it needs to be less than. Not less than or equal to, it's just less than. So the area is less than 55 meters squared. I'll write that down there. Well, we don't know the length and we don't know the width. We do, however, want to put down some type of variable. I'm going to use x. Let x equal the width. So that means now the length is going to be 3 meters greater than twice the width. All right. So area is equal to length times width. And just fill it in. Our area is 55. And actually I'm going to write it the same way that I wrote it up over here. The area, which is length times width, so length times width, has to be less than 55. The length, which was 2x plus 3, multiplied by the width, which was x, has to be less than 55. Let's expand that. So 2x squared plus 3x has to be less than 55. That's equated to 0. 2x squared plus 3x minus 55 is less than 0. We treat it exactly as we did the other questions. Factor it, or if it's not factorable, quadratic formula. And in this case, it's not factorable, so we would have to use the quadratic formula. If you get any negative answer in the quadratic formula, that's extraneous. We don't need it. We're not going to use it. And that would be the case here, as we would get a negative as well. So we're only going to look at the positive side. And if you did the quadratic formula, again, the quadratic formula was x equals negative b plus or minus square root of b squared minus 4ac over 2a. And we need to make sure that it goes to a positive value. So we're going to be doing the adding. And working that through for yourself, you would be able to get up with 4.5474 dot dot dot. Okay, so just logically thinking this through, at an x of 4.5-ish, it's going to equal 55 meters squared. Because that's what your 0 does, is it makes it equal. If we went less than that number, if we made the width less than that, then the area is going to be smaller. I don't have to do the test cases, because I can logically think that one through, is that in this situation, we're talking about area. Anything bigger than this width will give us a bigger area. Anything less than this width will give us a smaller area. So we know that the x has to be less than 4.5. Really 4.5474 ... all the way along. So we want a width to be less than approximately 4.5 meters. And the length is going to be 2 times that, plus 3 more. So the length is 2 times 4.5474 ... plus 3. We're going to get approximately 12.1 meters. So the width is to be less than approximately 4.5 meters, and the length to be less than or approximately 12.1 meters. If I used 4.5 and if I used 12.1, I would be less than 55 meters squared, because 4.5 is slightly less than the decimal version that I had there. Okay, so go through to finish up your discuss the ideas on the bottom of the page there.